Okay, so level threes, kind of in context here and just maybe a little bit more difficult. It says plot the points of A, -4, 0, and 0, -4, and 4, 4, and connect them to form triangle ABC. Find the area of the triangle. The formula of the area of the triangle is 1/2 base times the height, which we talked about last objective, but it's there for you to remember there anyway. So I'm going to go ahead and plot these points, -4, 0, so here's A. We also have 0, -4. And 4, 4. So we've got a big old triangle here. So now what we want to do is we want to find the area of the triangle. So in order for us to find the area of the triangle, we need to figure out the base and the height of this triangle. So what I would do from here is find the lengths of each of the sides of the triangle and then see what that gives me. So I'm going to use the distance formula in order to do that. So first I'll find AC. Get -4 minus 4 squared plus 0 minus 4 squared. So this is going to be -8 squared, which is 64, and -4 squared, which is 16. And if I add those together, that's going to be 80. So if I break 80 down, 80 can be broken down into 16 and 5, and 16 is 4 and 4. So I should have 4√5 for AC. Now I'm going to do the same thing for BC, from 0, -4 to 4, 4. So BC is going to equal the square root of 0 minus 4 squared plus -4 minus 4 squared. So this is going to be -4 squared, which is 16, and -8 squared, which is 64 again. So BC is going to be the square root of 80, which equals 4√5. So from just doing those two distance formulas, I know that AC and BC are congruent. So I know at least that those are isosceles triangles. So now let's go ahead and find AB and see what happens from there. So if A is at -4, 0, and B is at 0, -4, let's go ahead and see what happens here. So -4 squared is 16, and then +4 squared is 16, so AB will equal the square root of 32, which can be broken down into 16 and 2 and 4 and 4. So we got AB to equal 4√2. So not equilateral, but it is definitely isosceles here. So this is 4√2. So again, in order to determine the area of the triangle, we need to know the base and the height. Well, since this is an isosceles triangle, then I'm going to draw off to the side here. This is ACB with AC congruent to CB at 4√5. and this is 4 root 2. Remember, if you draw in the height of an isosceles triangle, that's going to cut the base in two, so each of these sides are 2 root 2. Now I can easily find the height using the Pythagorean theorem. So I'll take 2 root 2 squared, remembering to put it in parentheses, plus the height squared, and 4 root 5 squared, again remembering parentheses because now I can square the 2 and square the root 2, and square the 4 and square the root 5. This can be broken down into 36 and 2, so 6 and 6. So 6 root 2 is the height, which leaves the area to be determined by area equals 1/2 the base, the whole base, which is 4 root 2, times 6 root 2. Now remember, when you're multiplying with radicals, you can multiply the numbers, so I'll multiply 1/2 times 4 times 6, and then I can multiply the radicals, 2 times 2. So I'll have area equals 12 times 2, which is 24. We'll just say units squared. Okay, so that's how you'd find the distance formula. Using the distance formula, that's how you would find the area of a problem. So for the second one, we got to define this word equidistant. Equidistant means basically what it sounds like, equal distance. So if I call this point A, this point B, and this point C, it says find the point where 0y, or point A, is equal distance from point B and point C. So what we want to know is when BA equals AC. So we're going to use the distance formula and just set those two equal to each other and solve. So this is where it gets a little tricky algebraically, but as long as you keep things kind of neat and straight, you should be okay. So grab a piece of scratch paper if you need to when doing these problems, and then just transfer your answer back onto your iPad. So if I'm finding the distance between A and B, I'm going to take the square root of 0 minus 4 squared plus y minus negative 9 squared. And then we've got the square root of AC, so the distance of AC. So we're going to go 0 minus 0 squared plus y minus negative 2 squared. And simplifying, 0 minus 4 is 4, and then 4 squared is 16. And then I'll have y plus 9 squared. I'm just going to leave it like that for now. That's going to be 0 for the first part, and then I just have y plus 2 squared here. So now if you have two things that are within a square root, square roots are going to cancel out each other. So they'll just be 16 plus, I'm going to go ahead and multiply this out. So it'll be y squared plus 18y plus 81 equals y squared plus 4y plus 4. Remember, when you're doing this, this means y plus 2 times y plus 2. So you need to do the double distribution or the box or FOIL or however you would distribute that. So then it's just a matter of combining. So since I have a y squared on both sides, they're going to cancel each other out. And I'm just going to continue combining like terms. On the left-hand side, I'll have 18y plus 97 equals 4y plus 4. So I'll get the y's on the left-hand side to be 14y equals So this one turns out a little bit ugly, but that is the correct answer. So now all that means is the point from the beginning here, the point 0, negative 93/14 is equidistant from 4, negative 9 and 0, negative 2. So equidistant means the same distance, so equal from one point to the other. So it's not necessarily a midpoint, but it could mean something like this. So if I have point A here, point C here, it could mean point B is up here and it's equidistant from A as it is from C. So you might find that useful when you're doing triangles with isosceles.